this nation to take a clearly leading role in space achievement, which in many ways may hold the key to our future on Earth.
It's one small step for man, one giant leap for mankind.
Today is a day for mourning and remembering. Nancy and I are pained to the core by the tragedy of the Shuttle Challenger.
The following program may contain coarse language, adult themes, and bad attempts at humor. Listener discretion is advised.
What is President Trump's goal? What is his vision? He wants to put an American flag on Mars.
Houston, Tranquility Base here. The Eagle has landed.
I am JEFF, also known as A Cosmic Bard over on X, and this is the Lost Wanderer podcast for March 8th, 2026, produced live from Listening Post Studio and simulcast on KLRN Radio. We're coming to you tonight from the ACS Serenade Observatory, orbiting high above the right night side of the Earth, where the lights of cities trace the continents below us. Satellites drift silently along their long arcs, and beyond that thin blue edge of the atmosphere, the wider universe waits in the dark. From this quiet vantage point, we keep watch on the rockets leaving Earth, the discoveries reshaping science, and the strange new ideas that remind us just how big and small the cosmos really is. And tonight, that push toward the future may actually be accelerating. Our lead story tonight, the new lunar race. For more than half a century, the moon has been quiet. The last astronauts to walk there, Gene Cernan and Harrison Schmitt of Apollo 17, left the Taurus Lindau Valley in December of '72. Since that moment, humanity's presence beyond Earth has remained close to home, limited largely to low Earth orbit aboard space stations like Skylab, Mir, the ISS, and the new Qianyang space station. But something interesting has been happening over the past few weeks. Across NASA, Congress, international space agencies, and private industry, a series of developments has begun to suggest that the long pause in lunar exploration may finally be nearing an end. Individually, these headlines might seem a bit routine, a rocket repair here, a funding announcement there, a policy shift in Washington, but taken together, they paint a picture that looks increasingly familiar to historians of the space age. Humanity may be entering the early stages of a new lunar race, and I'd like to welcome everyone stopping by and listening to this show. I greatly appreciate it. But the first place of that story begins with the rocket that will be carrying astronauts back toward the moon. According to reporting from Space.com, NASA engineers recently completed repairs to the rocket that will be powering the upcoming Artemis 2 mission, the first crewed lunar mission in more than 50 years. Now, Artemis 2 is designed as a 10-day mission that will send 4 astronauts aboard the Orion spacecraft on a journey around the moon and back to Earth. Now, this flight will not land on the lunar surface, but it will mark the first time humans have traveled beyond low Earth orbit since the Apollo era. Some questioning on that, whether the Jared Isaacman group was above low Earth orbit or not, but because they're actually leaving the gravity of Earth for the most part, we're going to give this one as first. The mission will rely on NASA's Massive Space Launch System, or SLS, the most powerful rocket currently in operation. Standing nearly 322 feet tall and capable of producing more than 8 million pounds of thrust at liftoff, this rocket is designed specifically to carry heavy payloads, including astronauts, into deep space. But before that mission can even fly, engineers have had to resolve a technical issue discovered during launch preparations. Now, once again, according to Space.com reporting, NASA teams identified a problem involving the helium system in the upper stage of the rocket, which helps regulate propellant flow and maintain pressure within the vehicle's fuel tanks. Helium systems may not sound dramatic, but they do play a critical role in rocket operation. Without proper pressure controls, propellant cannot flow correctly through the engines, and the vehicle cannot perform as designed. Engineers ultimately traced the issue to a component within the system and carried out repairs to restore proper function. With that work now completed, NASA says preparations for Artemis II are continuing as the agency works toward this next phase of testing and integration. Now, when it does launch, Artemis II will carry 4 astronauts, including NASA astronauts Reed Wiseman, Victor Glover, and Christina Koch, along with Canadian astronaut Jeremy Hansen, as long as he's still not too pissed off about America beating Canada for the gold medal, on a mission that will take them roughly 230,000 miles from Earth, looping around the moon before that journey to beautiful terra firma. Now, this flight will serve as a critical systems test for Orion's life support systems, navigation, and communications, all essential capabilities before astronauts attempt a lunar landing. That said, Artemis II is only the first step, because behind the scenes, NASA is already reconsidering parts of the broader Artemis plan, and those changes could reshape how quickly humanity does in fact return to the moon. Once again, according to reporting for Space.com, NASA officials have been reassessing key parts of the Artemis architecture as the agency works to balance technical risk, cost, and schedule in its effort to return astronauts to the moon. Now, originally, Artemis 3 had been envisioned as the mission that would place humans back on the moon for the first time since Apollo 17. And of course, that mission would use NASA's Orion spacecraft to carry astronauts to lunar orbit, where they would then transfer to a commercial lunar lander for the descent to the surface. Now, those landers are being developed by private companies under NASA contracts, most notably SpaceX, which is developing a lunar variant of the Starship spacecraft, and Blue Origin, which is working on a competing landing system as part of a separate NASA program. But integrating all of these elements, a new heavy lift rocket, a new deep space crew capsule, and a completely new generation of lunar landers has proven extremely complex. NASA officials have increasingly emphasized the need to test these systems in stages, rather than attempting too many first-time operations in a single mission. That has led to discussions about adjusting its timeline and mission sequence for Artemis. Now, instead of attempting an immediate lunar landing, some Artemis missions may focus first on testing rendezvous and docking procedures between, say, Orion and the commercial landers, ensuring the spacecraft can safely transfer crews before committing astronauts to the final descent. The change reflects a lesson learned repeatedly throughout history of spaceflight that they still somehow didn't think of. Complex systems are safest when introduced step by step. During the Apollo program of the 60s, NASA conducted a series of progressively more ambitious missions, testing spacecraft in Earth orbit, then lunar orbit, and only after attempting all of that, the final landings. Artemis appears now to be following a similar philosophy. NASA officials have indicated that the first new lunar landing could occur more late in the program than originally deceived, potentially during Artemis 4, once both the Orion spacecraft and the commercial landers have undergone further additional testing. That approach may delay the historic return of astronauts to the surface, but it also may increase the chances that when humans do finally return, the mission has a greater chance of success. And let's face it, the stakes for that success are enormous, because unlike the brief visits of the Apollo era, Artemis is designed to do something fundamentally different. We're not just there to visit the moon, but building a long-term human presence there. And that ambition is one of the reasons NASA is now exploring, believe it or not, well, not hard to believe because we actually have a good NASA leader now, is now exploring ways to move even faster, because the race to the moon is not going to wait forever. Now, NASA officials are studying whether the pace of the Artemis missions could be dramatically accelerated once the program reaches full operational capability. Now, under the original plan, major missions to the moon were expected to occur roughly every 2 to 3 years. That slow cadence reflected the complexity and cost of deep space missions, as well as the time required to manufacture new SLS rockets. But some planners inside NASA now believe that schedule is actually too slow for the ambitions of the program. Oh my God, one man takes over and NASA gets smart again. If achieved, the tempo would resemble the pace of the Apollo era when NASA launched multiple lunar missions in rapid succession between 68 and 72. Accelerating Artemis to that level would require some major changes, however. NASA officials have been considering whether certain elements of the current architecture could be simplified in order to support a higher launch rate. One example involves the massive ground infrastructure required for the SLS rocket. NASA has been developing a second launch platform known as Mobile Launcher 2, intended to support future upgraded versions of the SLS rocket. But the platform has grown extremely expensive, with projected costs reaching in the billions with a B of dollars. Some at NASA are now questioning whether that platform is even truly necessary, or whether abandoning it could actually free resources to support more frequent missions. Another area under discussion involves the Gateway Station, a small space station originally planned to orbit the moon and serve as a staging point for astronauts traveling to the surface. Now, Gateway does remain an important part of NASA's long-term vision for lunar operations, particularly for international partners such as the ESA, Japan, and even Canada, if they're still not butthurt. But some officials have suggested that early Artemis missions might operate without Gateway in order to simplify the planning. All these discussions point toward the same underlying question. How quickly can humanity realistically establish a sustained presence on the moon? Because the faster those missions occur, the sooner astronauts could begin building the infrastructure, such as habitats, power systems, research facilities, that would transform the moon from a destination into a permanent outpost. And that urgency is not just about exploration. It is also about competition. Because while NASA is trying to accelerate its lunar program, political leaders in Washington have begun speaking openly about something that has not been heard in decades: a space race. And that sense of urgency is beginning to show up in Washington. Now, according to reporting from Ars Technica, a United States Senate has recently passed legislation intended to strengthen NASA's ability to compete in what lawmakers increasingly described as a renewed lunar space race. This measure is part of a broader effort by Congress to ensure that the United States maintains leadership in human space exploration during a period of growing international China competition. Because in recent years, China has significantly expanded its lunar programs, including robotic landings on the moon's surface and long-term plans for Joint International Lunar Research Station. And these ambitions have caught the attention of policymakers in the United States, who increasingly view the moon not as a scientific destination, but as a strategic frontier. Now, the Senate legislation encourages NASA to move more aggressively with its Artemis program and emphasizes the importance of establishing American and allied infrastructure in the lunar space before competing powers can do the same. Lawmakers see the next decade as a critical window for shaping the future of human activity beyond Earth. And the reasoning is, well, it's actually kind of simple. The moon occupies a central position in the Earth-Moon system, making it an ideal location for communications networks, navigation systems, and staging areas for missions deeper into the solar system. Whomever is able to build that infrastructure first could influence how the next century of space exploration actually unfolds. And that reality is finally beginning to drive political momentum behind NASA's lunar ambitions. And while the governments are debating this new lunar strategy and space agencies refining their mission timelines, we cannot forget that private industry is moving forward with plans that could reshape how much humans live and work in orbit. And back to space.com, according to reporting from them, the California-based company Vast has now raised approximately $500 million with an M dollars in new funding to continue development of its Haven series of commercial space stations. The company says the investment will allow it to expand manufacturing capabilities and accelerate development of the first orbital habitat known as Haven 1. Haven 1 is designed as a relatively small but highly capable station intended to operate low Earth orbit. They're in California. Why don't they make a dang TV show and take the profits from that? As we were talking kind of on Vincent Charles' project. The station is expected to launch aboard a SpaceX Falcon 9 rocket, and once in orbit, it would provide a pressurized habitat where astronauts would and could conduct experiments, perform maintenance operations, and demonstrate technologies that will be needed for future space infrastructure. Now, for most of the space age, orbital stations were these massive national projects. Once again, Skylab, Mir, the ISS, and whatever the Chinese are doing, were all built and operated by governments, requiring decades of international cooperation and billions of dollars in public funding. But as launch costs have fallen and private investment has increased, a new generation of companies is beginning to see orbital habitats as a viable commercial industry. And NASA, to its credit, is encouraging this transition. The agency has been working with commercial partners in hopes that a privately operated station will eventually replace the ISS, which is expected to retire near the end of this decade after more than 30 years of mostly continuous human presence in orbit. And stations like Haven 1 are intended to be the early steps toward that future. According to VAST, the long-term goal is to develop larger stations capable of supporting permanent human crews, research laboratories, and potentially even manufacturing facilities operating in microgravity. And while these stations are initially planned for low Earth orbit, they do represent the beginning of something, just something, potentially much larger. Because if and when the humans return to the moon, or for the first time, depending on your stance on that, and we eventually travel onward to Mars, the infrastructure that supports these missions will likely begin in low Earth orbit. And companies like VAST are betting that the next era of space exploration will not be built by governments alone. But that still doesn't answer kind of one question. With all these rockets, lunar programs, and commercial stations dominating the headlines, there's another topic that occasionally drifts into public conversation about space. Yes, UAPs, or as some of us olds remember it, UFOs. But according to reporting from Ars Technica, the leadership of the United States Space Command is urging caution when it comes to speculation about mysterious objects in orbit. It's probably theirs. I may have added that last part. During recent remarks, the commanders of the U.S. Space Command addressed questions about whether unidentified objects might be operating in space around Earth. His answer was actually direct. Quote, "The military has not found evidence of alien spacecraft or unexplained vehicles operating in orbit. Instead, officials say the objects tracked by the military space surveillance networks almost always turn out to be something far more familiar. Satellites, fragments of old spacecraft, pieces of debris left behind by decades and decades of launches. And yes, Space Command is responsible for monitoring tens of thousands of objects orbiting Earth, using radar systems and optical telescopes to track everything from functioning satellites to fragments as small as just a few centimeters across. That catalog now includes more than 40,000 tracked objects, with millions of smaller pieces of debris that we are calling dinklages are also believed to be orbiting the planet. According to the Ars Technica report, when unusual objects are detected, analysts typically discover they are simply previously unidentified satellites, rocket components, or fragments created by past collisions or anti-satellite tests. Looking at you, China. In other words, space is a little crowded, just not necessarily with alien spacecraft. Now, this doesn't mean the tracking effort is unimportant. In fact, it's actually probably more critical than it ever has been. With thousands of new satellites launching every year, including large constellations designed to provide global internet coverage, the number of objects in orbit is growing rapidly. Tracking them accurately will help prevent dangerous collisions and protect astronauts aboard spacecraft like the ISS. It also ensures that military and commercial operators understand exactly what is moving through Earth's orbit environment. So while speculation is great about mysterious visitors from deep space continues to capture public imagination, hello, I'm here, the reality, at least according to the people watching the skies most closely, appears far more practical because we've already landed. Right now, though, the biggest challenge near Earth is not unidentified craft. It really is orbital traffic. Now, before we head toward the intermission, it's time for a quick look at one of the less inspiring sides of the modern space race. Now, most of the stories, yes, so far have been about innovation, new rockets, new missions, new ambitions of pushing humanity further into the solar system. But space exploration also has a long history of bringing along something else. Geopolitics. So every once in a while here on the Lost Wanderer podcast, we go, we're going to shine a light onto the moments when the politics of Earth follow us off planet, which, yes, it means it is time for tonight's installment of...
And now, Assholes in Space!
China is asshole! China is asshole! China is asshole! China is asshole!
Yes, tonight's entry, China's race to the lunar South Pole. China's lunar exploration program has been advancing steadily for years, and the next major step in that plan is a mission called Chang'e 7, currently scheduled for launch sometime in 2026. The target is the South Pole of the Moon. If that location sounds familiar, it absolutely should. It's the same region NASA is planning to explore with its Artemis missions, because scientists believe permanently shadowed craters there may contain deposits that are a significant size of water ice. And water is the key resource everyone is chasing. It can support astronauts, it can be turned into breathable oxygen, and perhaps even more importantly, it can be split into hydrogen and oxygen to create rocket fuel. In other words, whoever learns how to extract and use those resources first gains a major advantage in building a permanent presence on the moon. And China's Chang'e 7 mission is designed to study that environment in detail. The mission will include an orbiter, a lander, a rover, and a small hopping probe capable of jumping into permanently shadowed craters where sunlight never reaches the surface. Those craters are among the coldest places in the solar system, next to my ex-wife, and they may contain ice that has remained frozen there for billions of years. Sorry about that. This mission is part of China's broader plan to place astronauts on the moon before the end of the decade. China has already made several major advances in lunar exploration. As my eyes are watering from my coughing fit, I apologize again. The Chang'e 4 mission made the first landing on the far side of the moon in 2019, and Chang'e 5 successfully returned lunar samples to Earth in 2020. The new focus is shifting toward the South Pole. But the difference lies in how these missions are going to be organized, between the difference between NASA and China. For you see, China is not a part of the Artemis Accords, the international agreement led by the United States to establish guidelines for cooperation and reasonable resource use on the moon. Instead, China is working with that juggernaut, Russia, and other partners on its own initiative known as the International Lunar Research Station, a project aimed at establishing a long-term robotic and eventual human presence near the lunar South Pole. So while NASA and its allies are building one international framework for lunar exploration, China is indeed building another, which means the most valuable real estate on the moon may soon host two competing visions for humanity's future in space. And let's face it, if this sounds a little bit like the Cold War, well, boys, apparently the space race is back on the menu, just with better rockets this time. And with that, we will be back in about 4 minutes.
Tracing the glow where the long darkness runs. Every horizon dissolves into night. Still there's a road in the bones of the light. Left me of echoes and radio fame. Point to a shore with no language or name. Something is calling beyond what we see. Pulling the compass inside you and me. Somewhere beyond the lands of the sky, where silent rivers of starlight run dry. There waits a God knows eyes going out. In the world, leave a wandering galaxies turn like a slow burning wheel. Still there's a distance our numbers can't feel. So we keep following faint silver threads, trusting the glow where the endless path spreads. So last night will the quiet begins. Maybe that road is where
And welcome back aboard the ACS Serenade, orbiting high above the night side of Earth. I'd like to take a few moments and thank everyone for tuning in. I see Sean over on YouTube. We have Al, who is, I think, still following us tonight. I haven't seen anything or heard anything. We have Orty, we have Delaney, we have VC, we have Raptor live in chat. Thank you guys for tuning in tonight and welcome me back. Lost Wanderer on its regular night. And eventually you'll find me in a couple more places. So that'll be exciting. But before the break happened, we were talking about rockets, lunar missions, and the increasingly crowded race to return humans to the moon. Now, for those unfamiliar with the program, the second half of the Lost Wanderer podcast is typically where we usually widen the lens a little. Because, let's face it, once you move past the politics of Earth orbit, the universe starts asking much bigger questions. And tonight's question is one that humanity has asked for thousands of years. And we know a Star Trek movie tried to explain it, and it failed miserably doing so, where exactly is heaven? Now, this question recently popped up in perhaps an unexpected place. A discussion in Popular Mechanics based on comments from Michael Pravica, a physicist at the University of Nevada, Las Vegas. Now, he wasn't claiming that science had discovered heaven. In fact, he was making almost the opposite point. If something like heaven exists, physics suggests it probably wouldn't be located somewhere in the universe at all. Modern cosmology describes our universe as a structure called space-time, a four-dimensional framework made up of 3 dimensions of space and 1 dimension of time. Everything we observe, from galaxies to atoms, exists within that space-time structure. But some theoretical models in physics suggest that space-time itself may only be one region of a much larger reality. In certain higher dimensional theories, our universe could exist as a kind of bubble or marble of space-time, embedded within a broader multidimensional structure. If that idea is correct, then it becomes possible, at least mathematically, that other regions of reality could exist outside our space-time bubble. And that's where Pravica's thought experiment comes in. He suggested that if a spiritual realm such as heaven existed, it would make far more sense for it to exist outside our universe's space-time rather than somewhere inside it. Almost like he listened to my episode of ITC that talked about this. God, I hate being... Anyway. Now, if heaven were located somewhere in the physical universe, on a distant planet or a hidden corner of space, in principle, we should eventually be able to detect it. But if it existed beyond space-time itself, then by definition it would be inaccessible to telescopes, spacecraft, or any instrument built from the law of physics operating inside our universe. Now, to be clear, he describes the idea as a philosophical speculation informed by physics, not a scientific discovery. Yes, there is currently no experiment capable of testing it, but the discussion does highlight some fascination and ideas about modern cosmology. The universe we observe, the galaxies, the stars, the cosmic web stretching billions of light years in every direction, may not represent the entirety of reality. It might only be one region of a much larger structure. And if that's true, then the oldest human questions about what lies beyond our universe may someday intersect with the newest ideas in theoretical physics. And if that wasn't enough, you needed a reminder that the universe still has a few surprises left for us. Astronomers recently spotted one of the largest explosions ever recorded since the Big Bang. And no, it didn't have to do with her. And surprisingly, it didn't come from a dying star. It came from a supermassive black hole. Once again, according to reporting in Popular Mechanics, astronomers studying distant galaxies detected a massive outburst of energy originating from the center of a galaxy where a black hole, millions or maybe even billions of times the mass of our sun, sits quietly. Most of the time. These monsters exist at the center of nearly every large galaxy in the universe. Remember when we didn't think black holes were, all we thought they were was just really bad Disney movie that should be remade and done correctly? But occasionally, something dramatic does happen. In this case, astronomers believe an enormous amount of gas, potentially thousands of times the mass of our sun, drifted too close to the black hole's gravitational pull. And once that material crossed that threshold, gravity took over. Instead of falling straight in, the gas formed a rapidly spinning accretion disk around this black hole, heating up to extreme temperatures as friction and magnetic forces compressed the material. And when that much matter begins spiraling toward a black hole at once, things, they tend to get violent, like really, really violent. And that result was an enormous energy release that astronomers say dwarfs the power of a typical supernova. Now, for those that do not know, supernova, the explosions that mark the death of massive stars, already rank among the most powerful events that we have observed in space. But the outburst reported in the Popular Mechanics story released hundreds of times more energy than a standard supernova, making it one of the most energetic cosmic explosions scientists have ever observed. Now, what even made this discovery, as if it wasn't strange enough, what it actually made even stranger is that the event didn't fade quickly. Instead of flashing and disappearing in weeks like a normal stellar explosion typically does, the energy output from the event continued shining for years, allowing astronomers to study the phenomenon as it unfolded. And go ahead and chat. We said phenomenon. Do, 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 do. Events like this, well, they're extremely valuable to astrophysicists. They do help researchers understand how supermassive black holes grow, and I know you're giving me the middle finger in chat, and I'm not going to look. But they do, besides understanding how black holes grow, but actually how galaxies evolve over billions of years, and how matter behaves in some of the most extreme environments known to science. They also remind us that black holes are not just cosmic vacuum cleaners swallowing and sucking in everything like moths behind a Circle K. Under the right conditions, they become engines of enormous energy, lighting up entire regions of their galaxies. And when those events happen, the signals can and do travel across millions, sometimes billions, of light years before reaching Earth. Which, if you think about it, means that somewhere out in the universe tonight, right now, a distant galaxy may be experiencing an explosion so powerful it briefly outshone everything else around it. And we might not even notice for a few million years. Crazy. Now, if the universe is filled with civilizations that are out there, not like a horrible reboot of X-Files that are incoming, but maybe there is some sort of truth out there about the civilizations of other planets. Mathematically, odds are in favor that, yes, they're out there. But when we start thinking about them scanning the skies for signs of life, as we often think of us scanning them, there's a greater than 0% chance we may have already introduced ourselves to them. Not on purpose, of course. I mean, we did send a gold disc with our address and nudes and a mixtape. That's a whole other issue. But according to research discussed in a recent science report, some of the most powerful signals leaving Earth today aren't actually meant for space at all. They're meant for airplanes. Follow me on this. It gets a little weird and a little interesting. Every day, airports around the world use high-powered radar systems to track aircraft moving through their airspace. These radar systems transmit strong bursts of radio energy that bounce off airplanes and return to ground receivers, allowing controllers to monitor traffic safely. It's a technology that has quietly guided aviation for decades. But let's do the logical thing here. The waves that don't hit planes, they tend to continue outward into space. And according to researchers studying how detectable our planet might be from afar, those radio transmissions could potentially act as some sort of cosmic beacon. The study examined the strength and spread of radar emissions produced by large aviation hubs, the kinds of airports that operate constant air traffic surveillance systems. These facilities transmit signals powerful enough even that when combined with the rotation of the Earth, they sweep large portions of the sky with repeated pulses of radio energy. From a distance, those signals would look very different from natural sources of radio waves. They would appear structured, repeating, and definitely artificial. In other words, exactly the kind of signal astronomers on another world might interpret as evidence of technological civilization. Notice I didn't say intelligent civilization because we are still searching for that ourselves. The researchers estimate that radar systems from major aviation centers could be detectable from distances of up to roughly 200 light years away. Assuming an alien civilization possessed a radio telescope comparable to the instruments we already operate on Earth. You know, like maybe the ones on or near. Let me pick one here at random. Alpha Centauri. They might have some radars capable of detecting this thing, but that's just a guess from me. Now, many of those systems host planets of their own, and if any technologically advanced civilization in that region happen to be listening as my phone goes off in the background, like it's trying to eat, Alpha Centauri is pissed off at me for relaying too much information, they might already know something unusual is happening on a small blue world orbiting a fairly ordinary little itty-bitty yellow star. What makes this idea actually, for me, particularly interesting is that it means humanity may have been broadcasting its presence unintentionally for decades. Oh, I don't know. Once again, picking a random number, 5.5. Long before deliberate attempts at messaging ET even became a thing. Only by a few years or a few months. Long before we had powerful planetary radar experiments. The everyday technology may have already leaked enough signals into the galaxy to announce the Earth host an industrial civilization. Now, granted, the easy thing here is actually detecting the signals. That's one thing. You could easily detect our signals coming. Interpreting them correctly, but that's a whole other ball of wax that we won't get into discussion here with. But from across interstellar distances, signals would likely appear as brief flashes sweeping across the sky as the planet rotates, a kind of rhythmic lighthouse signal repeating every 24 hours. But to a curious astronomer studying distant planets, I don't know, say from Alpha Centauri, that pattern might stand out immediately. It's a rotating world with artificial radio transmissions, which means that somewhere within a couple hundred light years of Earth, say 4.19276, but rough estimate, someone might already be wondering, who is this planet full of? And why? God, why is our planet sounding so busy? And you got time now. I'm actually wrapping up early tonight. I wasn't feeling well when I wrote the story, when I wrote shows tonight, so I'm probably going to end up 5 to 10 minutes early tonight. Because our final story tonight takes us to the most hostile environment on Earth. No, not my ex-wife's house. A place so dry, a place so dry, sun-blasted, and so barren that scientists often use it as a stand-in for another world. The Atacama Desert, which I know I pronounced wrong, in northern Chile. And according to research highlighted in Popular Mechanics, what scientists are finding there may help answer one of the biggest questions in science. How do we find life on another planet? Now, the desert is often described as the driest non-polar desert on Earth. In some regions, measurable rainfall can go years without occurring. The ground is saturated with salts. The sunlight, intense. The ultraviolet radiation from the sun reaches levels that would quickly damage most forms of life. Now, on the surface, it looks almost completely lifeless. But appearances can be deceiving. Scientists studying mineral formation in the desert have discovered that certain salt crystals create tiny microenvironments capable of protecting life. These crystals form naturally when salty water evaporates and minerals solidify in the geometric structures. Inside of those little itty-bitty structures, something remarkable happens. And no, it's not Peter Dinklage's house, I know. It is small pockets of moisture that can become trapped within the crystal itself. Those microscopic pockets act like miniature shelters, shielding microbes from harsh ultraviolet radiation while also retaining just enough water to allow life to persist. Researchers have found microorganisms living inside these crystals, organisms that survive in conditions far too extreme for most life on the surface. And that discovery is exactly why planetary scientists are now paying attention. Because similar minerals have already been detected on Mars. Orbiters and rovers exploring the red planet have identified large deposits of evaporate salts, the same type of minerals capable of forming crystals that trap moisture. If microbial life ever existed on Mars, or still exists today, these salt formations could provide one of the few environments where it might actually survive. Instead of searching randomly across the massive Martian landscape, future missions may focus on mineral structures that naturally protect life from radiation and dryness. In other words, if microbes are hiding anywhere on Mars, scientists suspect they might be hiding inside the rocks themselves. And the implications, well, they stretch even further. Similar mineral environments could exist on icy moons, such as Europa and Enceladus, where salty oceans are believed to exist beneath the thick shells of ice. The lessons scientists are learning from Earth's harshest desert are simple, yet they may end up being profound. Life doesn't always need a comfortable environment. Sometimes it only needs a tiny pocket of protection. And if you think about it, organisms that can survive inside crystals in one of the driest deserts on Earth, then somewhere out there in the solar system, life may already be quietly doing the same thing. And now it's time to look up at the night sky for the Celestial Watch. Your look at what's happening overhead in the next couple of weeks. Now, the moon actually reached full moon earlier this week on March 3rd during the full moon tradition known as the worm moon. And I'm not going to go into the Native American things because it's in the past. I only do that for future moons. And by the time we are talking tonight on the broadcast of March 8th, the moon has moved into its waning gibbous phase, still bright but shrinking a little more each night, roughly about 75% illumination, as it heads toward the last quarter on March 11th. The good news for sky watchers is that the moon now rises later in the evening, because some states, God, I hate the time change. Anyway, the much darker skies earlier at night, they're perfect for catching some of the winter's final constellations before they disappear the season. You know, once you get through all this physical time change crap. Now, if you happen, maybe look toward the southwest after sunset, you'll still see Orion, the great hunter, slowly leading toward the western horizon, and the red supergiant Betelgeuse marks his shoulder, while the brilliant blue star of Rigel anchors his opposite foot. Just below Orion shines Sirius, the brightest star visible from Earth, blazing in the constellation Canis Major. When Sirius is low in the sky, it often flickers with flashes of brilliant color as its light passes through the thicker layers of Earth's atmosphere. Meanwhile, the Big Dipper is climbing higher in the northeastern sky, one of the classic seasonal signals that spring is beginning its slow return and baseball is near. Planet watchers have a couple highlights this week as well. Look low to the western horizon shortly after sunset, where Venus shines brightly as the evening star. Around, tonight, Saturn sits very close to Venus in a twilight sky. Through Saturn, Saturn will appear much fainter and can be difficult to spot against the bright glow of the sunset. Further up in the evening sky, Jupiter remains the dominant planet of the night, bright and easy to see for hours after sunset. Mars, by contrast, is less favorable right now, unfortunately sitting a little closer to the sun in our sky and proving difficult to observe. And as the moon continues to wane toward that last quarter this week, guys, take advantage because as they grow darker, you will get some excellent viewing conditions if the weather cooperates. So if the clouds clear tonight and temperatures stay as they are, maybe step outside for a moment after our show and take a look upward because somewhere between the fading constellation of winter and the rising stars of spring, the universe is quietly changing season above us. So that's it for tonight's transmission. Thank you for tuning in whenever, however, and why ever you do. Thank you for allowing me my little break. I got a lot done during the break. I hope you like the new layout of the ship and the program. And there's some more features that will be, well, let's just say listening to a podcast is one thing, but I hope to make the show watchable and enjoyable at the same time. Special thanks to NASA, SpaceX, Space.com, Ars Technica, NASA Spaceflight, Popular Mechanics, and everyone out there keeping humanity's eyes to the stars. With me at the helm and the executive producer plotting the next course, and with the ship's computer in the back whispering the star maps we need through all the static. This has been the Lost Wanderer podcast. I have been the host, JEFF. Until next orbit, I hope you enjoyed the show. Learned a little, or maybe learned a little something. I don't know. And hopefully, maybe had a laugh as well.